Yo, what's up everyone? Colby Cheese here, and I am going to be giving you guys a presentation I did recently at IBM on functional reactive programming for beginners. And the goal behind this talk was to try my best to demystify some of the really crazy technical jargon around learning functional programming and show you how that you can actually begin using functional techniques today to actually get things done in a better way. So what is this all about? Let's take a look at why should you even care? Like what is the point? You know, what problem does this solve that you should even be interested? Well, a couple of things are that functional programming is a method of coding that's going to make your code extremely easy to test. It's going to make it very easy to read and reason about. You'll be able to avoid a lot of very confusing problems and errors that occur in your code, which are very hard to debug in many cases within object-oriented programming. It's also very fun to write, at least in my opinion, and it's the future, dude. So you got to do it. And this kid approves. Yeah. So we've all been there, right? Spaghetti code. Oh no! This might be, if we were to draw a diagram of some big project that you've worked on, this might be what it looks like. Functions and methods, classes, they're touching all different pieces of your application. Maybe a function changes something here and it changes something in the thing that it calls it. Who knows? Like everything has hands in everything, and there's no real single source of truth. Angular, I'm looking at you here. So the two-way data binding, no good. Now I'm not going to go into architectures, but there is a lot of frameworks out there that seek to address this data flow issue. You may have heard of React's, one-way data flow thing, and the way that Redux is trying to solve that, where it's actually inspired off of the Elm architecture, where there's this singular unidirectional data flow where nothing knows about the other part necessarily. You have a view, it goes to the screen, user mouse happens, and then you have this update function, it goes back to the model, and then just circular. And then of course Redux is very similar, but it's just got this one store of data, and then everything loops through that. But I'll be getting back to those later in the talk. For now though, why is everyone not using functional programming if it's so good? Well, the reason I think that this imperative style of programming, this object-oriented programming decided to take hold was that computers weren't very fast in the very beginning of when we were writing code, and you couldn't write multiple functions that recursively called each other, which is kind of how functional programming works. You had to run everything imperatively, like line by line, like go to line. I don't know if you've ever seen those old screenshots of older languages, go to line. That was how you had to code. And so, but now things are faster. That's not an issue. And also people are finally starting to hear about functional programming again. Now that React is popular, now that we have this Redux framework, is actually bringing functional concepts and ideas to massive amounts of people in the web development space. And so more and more people are going to be hearing about functional programming. That's why I was like, this is the future, dude. And it's amazing. So let's really start talking about it. Let's break these functional ideas into human speak, because I'll be honest with you guys, whenever you try and start looking up functional programming ideas, you just start Googling stuff, or you follow links that people sent you, it really does start to feel like an elite society. It's really confusing. You're like, what the hell is all of this jargon that is being spit out, And so, I mean, you got these things like monads, monoids, functors, lazy evaluation, currying, function composition, pattern matching, map, fold, reduce, merge, pure versus impure, polymorphism, blah, 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 blah. And then eventually you're just like,
what the fuck?
Yeah, that's your brain. So one thing to keep in mind, all of that stuff that I just said, and things like map, filter, reduce, that's probably the things that everyone hears when they think functional programming. Those are not functional programming. In fact, those are just the tools that will help you provide pure input, output, and to avoid the side effects that occur within imperative code and between, object-oriented code. And I'll be talking about that stuff and how it relates in a little bit. So What is a functional language, though? Let's talk about that. Well, simply put, a functional language is just simply a language that provides the tools and the framework and the best practices, etc., or whatever, to enforce these functional ideas that I'm going to be talking about more strictly. And so when you think of functional programming, you might be thinking, oh, I'm going to have to use these languages like Haskell, ClojureScript, Scala, Lisp, whatever. These are like what you would call a pure functional language. But you can use functional programming ideas and concepts within JavaScript, which you probably kind of had that in your mind or you knew that already. But that's just so you know, like these are just like pure in the sense that they enforce functional programming at a much more strict level. So what is functional programming? Well, I've kind of mentioned it before, but it's about side effects, mostly avoiding them, unlike this dude. So a functional method is pure, and pure methods or pure functions, as opposed to impure, will avoid side effects, kind of like an agent. So let's start taking a look at some examples. I've been, talking conceptual, but I've always learned better from examples. So what does a pure versus impure function look like? Well, first off, keep in mind when we look at these examples that pure functions have the following attributes. The one and only observable output is the return value, okay? So if you keep putting a set of parameters into a function, x and y, you're always going to get the same result if you always put in the same set of inputs. The only output dependency is the arguments. So, the output depends on the input. And the arguments are fully determined before any output is generated. So, there you go. All right, let's take a look at some examples. Pure versus impure functions. So, an impure function, this is an example. You may have a square function, and you pass in x, and it returns x times x. Cool, but at the same time, it also updates x in database. So that's what you call a side effect. You're not going to get the same result every time, because every time you call this function, you're changing something somewhere else. Now, square all. This looks like you're not changing it in the database, right? Well, in this case, you're passing in an array of items, for example, and then you're storing the state of I and changing that constantly within the function. And then if you think about it here, what's actually happening is you're actually updating the items array, which is, by the way, a huge no-no, because if I'm calling a function, I don't know exactly what it does, and I give it a parameter, I pass in a parameter, and then it alters the thing that I pass in. That's a huge recipe for disaster, and that's exactly what's happened here, and this is what you would call an impure function. So that's a huge side effect. Whereas if you look at a pure function, square x, it simply does the x times x from previously, or in the case of square all, it returns a new array with the thing that you wanted, okay? So items.map square, just pretend square is like a method that squares things. So, cool. Let's talk about a non-functional joke. Yeah, I love dad jokes. Here we go. So the instructor says, what's 5 plus 2? Number 5. Function plus number 2, 7? Yes, correct. But what's 5 plus 3? 8? Nope, that's wrong. It's 10 because we turned 5 into 7, remember? Yeah. Anyways, so more input-output stuff. Let's talk about input-output. All right, so this function right here has hidden side effects. It has hidden input and output. So let's take a look at it. You got a function called add user, and you pass in user. What is the hidden input here? So even though you're not adding as a parameter database is actually what you would call a hidden input, because even though you didn't specify database in the params, it still uses database. So that's what you call a hidden input. If you never looked at the inside of this code, you just saw the function name, you wouldn't know that database was a requirement for this function. And then it updates user count. That's another one. That's an output, I would say, input and output. Like you didn't know that it needed user count variable. That's I guess, a global variable in this case. And then it calls the notify component create toast, which toast messages, those little things that pop up. So yeah, this thing does a lot, right? So let's look at another one. So this is just, I'm just using the same example from before, similar example. This is more of a declared IO. If JavaScript, obviously all of my examples are in JavaScript, but if JavaScript had a type system, this is what the type signature would look like of a declared function. So you say square equals x comma y. You know, it takes two numbers, and you know that you will always return a number. In this case, returns x times y. So that's actually cool practice, by the way. If you're writing methods and you really want to make sure that you are writing pure functions, always declare what the inputs are going to be, and always declare the outputs. And by the way, if you're writing more functionally and you just want to try and think about like how can I make my methods more pure, always ask yourself, like if you see like a void function, in other words, a function that either doesn't take any inputs or doesn't return any outputs, that's a huge code smell that should tell you, something's wrong about this function. If it doesn't take anything and it doesn't return anything, that's a clear example that something is wrong with that function, because that's exactly the only thing that it should be doing, is taking the end parameters and returning the value, but never making any side effects. All right, so here's another one. How can this be improved? Get current program. So we pass in TV guide, we pass in channel, and then, so this looks fairly good, right? We say schedule equals TV guide, get schedule at channel. All right, so far so good. And then we return schedule program at new date. There's your problem, date. So let's think about this. Time is one of the biggest issues that you can have when programming, especially, now I said this at the very beginning of the talk, like why you want to know functional programming. Time is so difficult to debug, and if you can't pass in the time to this method, that's going to be very difficult to test later if you're having some kind of date that potentially is, or some kind of bug later that is potentially related to your, maybe like a time zone issue. There's all kinds of problems with dates. So a better way to write this would be to declare date as a dependency to this method here. And I'm using that same little comment style just so you can see. So you say, okay, I'm going to pass in a guide, a channel. This time I'm actually going to pass in the time, and then I'm going to return the program. Okay, so same as before, schedule equals blah, blah, blah. And then we return schedule dot program at that time. Okay, so imagine yourself, and I know a lot of people are not into testing, but for those of you that are, this will make more sense. But if you actually had to test this, you would have the ability to black box it out. You wouldn't have to worry about, well, I don't know what's going to happen with the date thing. You always pass in the same result, always get the same, pass in the same input, and always get the same result. And that's exactly what you want when you want to test things. All right, so hopefully that sort of is starting to click and make sense. So this is kind of close to what functional reactive programming is. It's not, but it's a good way to envision it in your head. So when you look at an Excel spreadsheet and you make a change in one row, and you have these calculations in other rows, those calculations aren't like listening to events and then changing state somewhere. They're simply calculating a value based on a value somewhere else. And that's pretty much what functional reactive programming is that you are simply just cascading down a bunch of changes based on a single source of truth. In this particular case, like a single source of truth would be like one cell that I actually do change. Obviously a program has to make a mutation somewhere, but the idea here is that I make a change in one cell, it changes the others that, that are like they just calculate things, all right? So that's one way to think about it. Now, what is reactive programming actually? So reactive programming is just programming with asynchronous data streams. All right, so what's a data stream? Well, it's an ongoing set of streams ordered in time. Okay, so if we had to think about a stream, let's draw it out. It's just, think of it as a line with a little arrow. You may have seen a diagram like this before. And then if we put some blue donuts on it, and that could be any kind of input event. So we're gonna talk about a click event in our next example, okay? So it could also be something like a user's inputting something in. It could be, you received a message from a server, or like you got a new tweet, or any kind of event that could be created arbitrary, but in our case, we're gonna use a click. Now, using this idea and combining it with functional programming, how would we model a double click? Okay, so let's walk through this little diagram here. And basically, if you had to model or program a double click, you know, some way to detect a double click with normal imperative or object-oriented programming, it could be kind of difficult. You might have to store like a state of, you know, like when was the last time they clicked, and store that in a date object, and then, you know, do some math based on that or something like that. But that can get kind of complicated. It's actually very simple when you're using like functional reactive programming ideas. So I'll just try and start at the top and follow me as best as you can. I'm going to go fairly quick, but so imagine the very top one here. You've got a stream, and every one of these dots is just someone clicking. Okay. Now maybe you're going to call a function called buffer, and all it does is, you know, click stream, which is this line, click stream, imagine, is the black line, dot throttle, and then you pass in 250 milliseconds. So what it's gonna do is gonna say, you know, it's gonna look, and if there's a bunch of clicks here that are happening within 250 milliseconds of each other, it's going to, basically it's going to put them together. So just imagine this function groups them together, okay? So now you have this new stream, right? Which has 4 values. Which are all lists, okay? So list of 1, 2, 1, 3, right? Now we're gonna map, in other words, we're gonna create a new array where we get the list length, okay? So now the new stream is just a stream of numbers, right? 1, 2, 1, 3. And next we're going to filter that list, and we're just going to return only the numbers that are greater than 2. And so now you have 2 values, 2 and 3. And there you go. You have only the values that are double clicks. Okay, so that's just kind of an idea of how functional reactive programming looks as a diagram. And believe me, that's way more simple than trying to do double clicks with imperative programming. So that's a fun one. All right, cool. So let's talk about some other like related ideas, and I'll try to like bring this thing all around and bring it to a head, as they say. So let's look at like DOM manipulation versus the way React likes to render things, and how like functional programming ideas will speed up your programs. So whenever you do things generally with like DOM rendering, you've got this thing where you'll run some kind of change in the code, and then the DOM will update. You run another change, you know, maybe it moves elements around on the screen. You do an animation, and then the DOM updates again. The browser resizes from the user, then the DOM updates. So this can be very slow when you have a lot of things happening on the screen. Maybe you guys have that happen where, you know, you click something and like the entire browser's like, and it's like moving around and things slow down. The way that React does it is that it's running all of those same methods potentially, but instead of manipulating the DOM every single time, what it does is it actually stores all of that data in this like fake DOM, which they call the shadow DOM. And it's just an object, and then at like each like time something is updated, or you know, during an animation frame or something, you call this react.render method, and then everything is instantly just updated once on the DOM, and so it's extremely fast. This is kind of similar to how like games are programmed with graphics, where they'll have like 2 buffers, and then a bunch of changes are made to one of the buffers, and then that buffer is flipped to the screen, and they just call that double buffering. But I don't want to confuse you, so I'm not going to even talk about that concept. So let's talk about Redux, though. So this is the thing that many of you may start hearing about if you've looked into something like React, because this is kind of the new way to model the actions and the state within your application in such a way that it removes the complexity within the inside of your code. And so let me explain kind of the idea behind Redux. You know, you can obviously spend a lot of time actually learning it and implementing Redux, but the whole point of it is that, you know, again, in order for your app to be useful, it has to do something somewhere. So you're gonna have to mutate something, right? Sure. But the idea behind Redux is that you want to pull out all of the mutations and all the side effects from your code, and you want it to be kind of like on the outside layer of your application. And that's what Redux does, is it has this thing called the store, where all of your state is stored, basically. It's just one massive object that knows about your entire application. And so you can imagine that as, this Redux is in general used for like local state within your application, but you can imagine that as a database, right? Like a database is that single source of truth of all of your application's data, potentially. But on the client side, Redux has this idea of a store, which is that object, okay? And then what it does is it just pushes down all of those objects and things. It reduces them down and sends them into your view provider, which, you may have all these little components built, which, instead of when someone clicks, you're not going to call a jQuery thing where you update an alert and, show or hide it. There's no showing or hiding. There's simply, a component that says, if my property is show, then here it is, or something like that. So you don't have to know about the rest of your application to function. You simply just have properties and you display them. And so that gets into the screen. Maybe the user does a mouse click, and then you have this thing called actions. So when a user clicks within your little component, your component doesn't change anything. It simply says, oh, here's an action, boom, and it sends out an action. Maybe and this is like you define these actions. So you have this thing that's like user clicked, or update count, or something like that. Like that's the action, but the component doesn't know what's going to happen when it sends the action update count. That gets done somewhere else, and another piece of code that runs your logic. So anyways, that's a very high level. That's all I'm going to talk about. Redux is inspired directly by Elm, and it's pretty much the same exact idea. And so you may have heard like model view controller. Well, Elm uses model view update, and every component will have a model that is, potentially the state of that component, and then it sends off stuff to a view. Same thing, screen, user, mouse. There's like an update function. In this picture, it says intent, but that's, update is where all of your logic happens, and then it sends it back to the model. And since Elm is a purely functional language, this works out beautifully. It's really awesome to code in Elm. Definitely check it out if you get a chance. Okay, so good. All of that chat is nice and all, but I haven't shown you how to do any map filter reducing or any of that fun stuff, right? I haven't actually gone into the weeds on that. And maybe you want to go deeper. Maybe these ideas that I've been telling you about have sparked an interest or a curiosity. And if so, that's good. So what are you going to do? What I suggest now, after watching this talk of mine, is really start with the basics. So do learn those tools. If you're not already doing this, please start using map, filter, reduce. Don't ever write, like if I never see a for or a while loop again, I would not be unhappy. Please never write a for loop again. Please use map, filter, reduce, other tools similar to that. So get these slides from me. I'll put them in the link, and there's a bunch of links in here. So I have some exercises that'll walk you through a lot of those tools and show you how to use them properly. There's this great piece on what is functional programming. It'll give you some more of the ideas, kind of reinforce the things that I talked about today. And then once you're comfortable with just the basic stuff, start looking into some of these other links that I've got. So I've got a link here called Getting Started with Redux. It's a video course on egghead.io for free. And even if you don't use Redux, just watching a couple of the first parts of these videos, it's really mind opening into oh wow, this is really cool. And it really talks about the creator of Redux. He's amazing, and he explains things extremely well. And also, as a bonus, if you're not really up to speed with a lot of the new ES6 stuff, he explains ES5 versus ES6 at the same time, and it's really awesome. So check it out. And then there's this thing where, so the reason I recommend that you go check out Elm language, even if you don't keep programming in Elm, just by spending maybe a weekend or 2 weekends going through this little video course here, build a reactive web app with Elm. Just learn Elm for a little bit, and you can it'll start opening your mind on like what is functional programming and how does it work, and then you can bring that back to JavaScript and you'll understand it so much better. Actually, what I did was I watched some of these videos. I learned Elm over like 2 weekends. I went back and watched this video course again. I was like, holy shit, I get it. Oh, it all makes sense now. And then after that, check out these reactive programming tutorials. Just look into Immutable.js. You don't have to start using it. Just like read through what it's trying to do. If you've learned Elm, you'll understand lists and iterables and why that's important. And so Immutable.js will actually make a lot more sense after you've learned Elm. And then if you really want to, you can learn Immutable.js. And then as like a more advanced and kind of fun thing, there's this little YouTube series called Classroom Coding with Professor Frisbee. And it's this little stop animation thing with this high-pitched professor. I don't know, it's really funny and goofy. It does go into some more advanced topics. Like earlier I was talking about the jargon like currying and functors and monoids, monads. He explains some of it, but it's still confusing if you're not in that whole space. So I put that as the last resource. I suggest going into these resources in order, okay? But anyways, thank you guys. If you've watched this far into the video, you are awesome and you're probably very smart. And so definitely ask me any questions if you have any, and thank you for sticking around. I'll see you guys. Be sure to subscribe and check out my blog if you haven't already. Peace out, bros.